15.3 Hamilton circuits. The Icosian game was invented by Irish mathematician William Hamilton in the mid-19th century. The game consisted of a wooden board, like shown, and 20 numbered pegs. At each vertex on the board, there's a hole for a peg. The simplest version of the game is as follows. Put the pegs in the holes in order, following along the edges, so that peg 20 ends up in a hole that is joined by an edge to peg 1. In other words, create a path that hits every vertex and ends where you started. Okay? I say path there, but it's kind of creating a circuit because we want to start and end at the same place. So I think the easiest way to do this is I'm going to start here and go around the outside over to C. So I went A, J, T, P, C. And then I'm going to move it inside here to D and go around this shape to H. So I went from D to K, Q, R, S, O, I, H. And then I'm going to go inside to G and go around this one to F. So that's G to N, M, L, and F. And then I got to work it back to the end. So I'm going to go back outside to E and up to B. And at this point, I'd be out of pegs. Okay. So, that's a path because we're finished. But if you think about it, we're trying to get back to A. So that would make it a circuit right there. All right. So we're trying to find a path from a vertex all the way around, hit all of the different holes in that board, and try to get back to where we can get to the start. That's a good illustration of a Hamilton circuit. A Hamilton circuit ends where it starts, okay? But it's a circuit that visits each vertex exactly once. Each vertex exactly once. If you remember the last lesson, an Euler circuit hit each edge exactly once and ended where it started. So notice the difference. Which of the following are Hamilton circuits for the graph? So remember, a Hamilton circuit is going to be a circuit that hits all of the dots. Okay, so A, B, E, D, C, F, A. And so your question is that a circuit? And did it hit all the dots? Okay, yes and yes, that's a Hamilton circuit. Then we look at the next one. A, B, C, D, E, F. Okay. And then it goes back to C, and we can already see that's a problem right there, okay? You can't hit a dot more than once, so I can already see this is going to be no. There's way too much going on. If I go from C to E to B to F back to A, that is a circuit, but that happens to be an Euler circuit. That hits all the edges exactly once. That's an Euler circuit, but this is talking about a Hamilton circuit. Hit each vertex exactly once and end where you start. Next one, B, C, D, E, F, B. Well, that's a circuit, but it doesn't hit all the edges or all the dots. Okay, it doesn't hit all the dots, so that can't be a Hamilton circuit. Two, find Hamilton circuits for each graph if possible. So really all you're trying to do is figure out a way to get all the dots, okay? Let's start with G. No, I can't do that. I can't do it that way because I can't hit I more than once. So let's try starting at I. You start at I. Oops. I can't do this because I'm going to end up having to go through I more than once. So since you can only hit each dot once, this won't exist. Okay, so not possible. For the second one, it's really easy. Don't get confused by all of the lines and all of the extra edges. All you have to do is hit all the dots and end where you started. So I think the easiest thing to do is just go around the outside. Okay, if I do that, I've got a Hamilton circuit. I hit all the dots. I ended where I started. That's a Hamilton circuit. So find the Hamilton circuit. I went A, B, C, D, E, F, and back to A. Notice I ended and started at the same place. There are other ways of doing this. That's not the only way. Question?
How come for the first one you can't go from G, H, I, J, K, like down?
Okay, let's see that. All right. So if we go G, H, I, J, K, that's fine.
Oh, but then it doesn't go back to the beginning.
But you have to, yeah, right. You have to get back to the start, and there's no way to do that without going through that I a second time. Okay? So great question. Thank you. Hamilton circuits for complete graphs. Remember, a complete graph was when you have however many dots, but they're all connected to every other dot. Okay, so like a K4 was 4 dots, and everyone was connected to every other one. So, something like this. That would be a K4. All 4 vertices connected to the other 3. Excuse me. But this says any complete graph with 3 or more vertices has a Hamilton circuit. And I think that's what this was right here. This was a K6. And it was pretty easy to find a Hamilton circuit. I just went around the outside. But this is saying any complete graph with 3 or more has a Hamilton circuit. Identical Hamilton circuits that differ only in their starting points are considered the same. So go back and look at this picture again. If I had instead started at B and gone around the outside and said B, C, D, E, F, A, B, that's the same thing. Okay, it doesn't matter. It's the exact same path. I just started at a different place. That's what that's saying. Hamilton circuits that differ only in their starting points are considered the same. Number 3, how many Hamilton circuits are there in each complete graph? So notice that's a K4. And in order to answer that question, just pick a starting point. Okay? Think about it. If you started at that point, point B, then you would have 1, 2, 3 choices for where to go from the start. Okay? So 3 choices, and then you're at this point, and then you've got either 1, 2, you've got 2 choices to get to the next spot. And so you pick one and you go here, and then at that point you've got to go here. You've only got 1 choice, and then you've got to go back. Okay? There are 6 Hamilton circuits, 6 different possible Hamilton circuits for that K4. On a, what is this, a K6? If you pick a starting point, notice you'd have 1, 2, 3, 4, 5 points to choose first, okay? And so you go to one of those points, let's say we're here, and then you'd have 1, 2, 3, 4 choices for what to go to next, and you can kind of see a pattern here. So then we pick like this one, and if you go to this point, then you'd have 1, 2, 3 choices for the next one. It sure looks like this is a factorial, okay? So then we go to this point, and you could either go to this one or this one next. That's 2. And then let's say we went to this point. You would be stuck. You have to go there. You've only got 1 choice. And then once you're at there, you'd have to go back to the start. So this is going to be 5 times 4 times 3 times 2 times 1. That is what? 120? 120. Okay. In general, though, a complete graph with n vertices has n minus 1 factorial Hamilton circuits. Okay, so put a star by that, box that in, something. That might come in handy later. A minimum Hamilton circuit in a weighted graph, remember that's with numbered edges. A minimum Hamilton circuit is a Hamilton circuit with least possible total weight.